Thank you, everybody. DataEngBytes. This is my first time actually talking to you in person, which is really exciting. The last time I was speaking, it was during COVID. So it was me alone in a closet looking at a screen trying to imagine that there was a lot of people interested in what I had to say. In some ways, that was less nerve-wracking. So hello, everybody, and thank you. Yes, Rishu, my co-pilot today as well, resident genius from Coalesce. So I'm the CEO, founder at a place called Lightfold. We specialize in implementation of the modern data stack, a boutique services company. But we're opinionated, as you will see. We have some views about the tech that we like to use and why we like to use it. And one of the pieces that we obviously wanted to show you guys, you would have seen the booth outside, is this cool new piece of tech called Coalesce. Now, the cool thing about the modern data stack is that you can compose it from all sorts of different things, and I'm going to talk a little bit about that in a sec, right? So we get that there are different shapes and different types of stack. But we think Coalesce is a really impressive addition to the arsenal for a bunch of reasons I'm kind of going to walk through. And then Rishu's going to show you the thing live, which I know is what everybody really wants to see. But before I do, I just want to dive in. So we look at data differently. We have looked at data differently for quite some time, even before we were Lightfold. We've kind of taken this view as we've gone on this cloud journey. I've been very involved in cloud literally from like the outset of putting things like Salesforce into practice for major organizations. And we think there's been a bit of a problem to some extent in the thinking. The way people have come to think about how you do cloud transformation is that apps are the center of the universe, right? So if we just park data engineering for a second, just talk about how do big organizations, small organizations actually approach the investment, the funding, the budgeting of digital transformation. What we're seeing very much is this idea of, and embracing the idea of specific apps for specific functions. And we can make them all interoperate and we can connect them, and that way we can get a bespoke system and system of systems for our specific go-to-market. It's very, very cool. There's just one problem. I was involved in some of the biggest transformations of that kind in the world for many years, and nobody ever thought about data. Data was literally, oh yeah, and then someone else will do migration. And I used to sit there going, when you say migration, you keep using that word. I do not think it means what you think it means. Because they would be sitting there going, we've completely changed the object model. Completely. Like, we thought that was a great plan. Oh, it was a great plan. I can see how that's more responsive to your business's needs. But the object model of the legacy data is completely different. So how are you going to get from there to there? And the big problem was that, particularly when you were doing a big legacy lift, the data is heavy. Yeah, so this is me warming up to my big hobby horse, and if there's anywhere where I'm going to get away with this one, it's going to be DataEngBytes, which is, we told you so. There's a whole bunch of us old bastards who did data modeling from back in the day. The people who taught me how to do this would have thrown me out that window for writing select star. And the reason that would have happened is because it would have run on a bit of racked tin that cost us $2 million from somebody in the back of the office, and it would have exploded, right? Now, that's not the situation we have today, but the important bit is not that I can write select star. The important bit is that for the last half a century of informatics, we've had to put a lot of research and understanding into the nature of structure of data, right? We had to really care about the structure of data. Now, what we've got is this incredible new opportunity where we've got unlimited cosmic power, right? We can scale out our compute and storage and everything else, and we've kind of thrown the baby out with the bathwater. We've had this moment where people have been too, I think, cavalier laissez-faire about what you need to understand to properly get data and informatics working at scale. And it doesn't matter. Machine learning, not impressed. Started in genetic science, right? Everything, statistics, yay. Super fast statistics, also yay. Mountains of linear algebra, yay with bells on, right? But it's still ultimately going to be as effective as the structured understanding of the data underneath it. Words like ontology, right? Hierarchy, classification. These are all being used by data scientists all the time. Those are also the terms that were used for data warehousing for 30 freaking years. So this weird tension that's evolving about don't talk to me about Kimball, don't talk to me about Inmon, don't talk to me about Data Vault. It's not about getting you to literally do it. Remember the select star comment. It's not about literally getting you to do it the way we did it 20 years ago or 10 years ago. Clearly, we don't have to. But to say that there's absolutely no value in it, huge mistake. And I think as people are realizing that's actually the key to digital transformation, we got to pull our socks up. Like we really, really do. I'm more and more having to get people to realize your traditional concept of OLAP, analytics processing, and OLTP being separate, I don't know if you got the memo, that's all coming apart. Absolutely every single vendor playing the game right now is falling over themselves to show you why not only is that not something we need to worry about anymore, all the value is being realized when we stop thinking that way. Why? Okay, John, you're saying a lot of things, controversy. Why? What are you going to put forward as the reason for why that's happening? Well, first of all, deal with the fact that your digital transformation initiatives get 10 times the budget you do. Just take that in. It's a safe environment. We can all be angry about it. I know we all are, right? But the reason that that happens is because the digital transformation initiatives make money. Part of what I've been doing for 15 years is talking to boards all over the planet going, data is a revenue center. Data is a revenue center. If it's a cost center, you're doing it wrong. And the reason why I'm very confident saying that is this idea. If you are in business and you are making money, and you show me something I can't connect in about 8 hops to the customer from a data perspective, I can show you something that probably won't be in your business in another 12 months. Because the way that you make money is ultimately to sell stuff to customers. And businesses remove things from their ontology if they are considered no longer core to that function. Any business, therefore, can be imagined very simplistically, lemonade stand, going into business, and recording the fact that they're selling lemonade to a customer. Now press fast forward. Assume they don't go out of business. That happens. It's an accretion process. Again, I'm talking very specifically here about private sector, governments, blah, 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 government 3.0. We could argue it's still citizen focused, but just humor me. Let's stay in private sector. If they don't go out of business, the customer is the core. It was always the core. It will continue to be the core, and everything will accrete around it. That's not how we were originally building data warehouses, because the original systems we built were more ERP aligned. They were more process function aligned. We had reference object models that were all about how do you store and process this powerful transactional data, which is cool and great. But there were people, even 30 years ago, arguing quite strongly for customer-centric data modeling. That is all I'm shouting. It's not even my idea. I'm not even claiming it's my idea. It's an old idea. And it's actually, I believe, the reason that the modern data stack's eating the earth. Because it means you can power personalization. And that is what the board actually wants. That is what the sales team actually want. That is what pays for your wage, my wage, everybody's wage. Because you figured out how to use the data to sell better, sell more, and to keep the customer longer. That is goldmine territory. They will sign off on the funding for that every day of the week and twice on Sundays. When we consider this then, in the context of this new world of cloud apps, right? We wind up with everybody building some version of, yay, I compose all my different Workday, Salesforce, all the rest of it, and they come in and they do a very specific functional thing. But the problem is, they all then proceed to say, oh yeah, but can you tell me that one thing? It's about the customer. Oh yeah, can you tell me that about the customer? Can you tell me that about the customer? All these questions start coming in about, let's call it 20% of the customer profile that isn't present in that specific system of record. And this is where digital transformations wind up becoming digital disasters, and I have been here, and I'm sure people in the room have, because they proceed to fix it with point-to-point integrations. Because that's the tool that the current implementer has to try and do the process integrations between those apps. But is that an efficient way for us to build a synchronized customer data pipeline? Is that an efficient way for us to simply synchronize the current view of customer? No. Everybody in this room is walking around looking at tools that are way more cost-effective and a lot easier to put in place than point-to-point integration. This one idea, the fact that we are now talking about asking this stack to power everything in the business that is making money and dealing with the customer, the collapse of OLTP, OLAP separation, is literally redefining the way we're thinking about commerce. It's redefining how we think about e-com. It's every time you talk about prediction, another little hobby horse because it's very relevant to Coalesce. Look, I've got nothing against you if you want to buy a feature store, right? It's the hottest new thing, but it made me spit out my teeth, right? The most important thing we can do now to increase the productivity of our machine learning people is to give them a feature store. Because it turns out that if you build pandas data frames 900 times to the exact same source, the exact same way, to do the exact same analysis, your data scientist gets bored as hell and thinks, wouldn't it be good if we just pressed save? In other words, a structured data table? Like a data warehouse or a data mart or something where we are then able to repeatedly use that data. No matter which way you cut it, no matter which way you slide it, we wind up coming back to the same idea, which is that the structure of the data is going to be incredibly important. Without it, you can't mobilize it. It's awesome that we've got this amazing new way to do unstructured data and soup data and lakes and everything else. But the way the business will unlock the value, machine learning or otherwise, is by establishing a structure, a schema that unlocks the value predominantly of the customer. Most of the machine learning use cases, particularly in direct-to-customer, are about anticipating customer behavior, increasing the likelihood of cross-buy, upsell, retention, right? They're all being fed on data points, unique features that are all dependent on a fantastic organization-wide understanding of the schema of the customer. All right, rant over. How long did that take? Have we still got time for you to do your demo? Okay, fantastic. I'll go really quickly. Modern data stack, I try to explain it with three things: mobilize, transform, and replicate. Again, I kind of assume that most people in this meeting, you're probably familiar with this. But if you're not, it's a good level set to figure out why he's shouting so much. Mobilize means more than graphs. Mobilize means more than graphs. Running Power BI, running Tableau, getting a really cool graph, it's a query. Getting a segmented audience, sending it to your automation tool, yeah, that's a query. Getting a feature store to augment a real-time inference to your latest super cool machine learning use case, that's a query. All of those are mobilizations of whatever that structure system is to an endpoint that converts it into value. And that's what's really changing in the language again in all the vendors, particularly Snowflake, this idea about mobilizing the data so that you can turn it back into money so that you all get paid. And that's why I don't hesitate to say, as engineers, if you're coming here as professional engineers, guys, if you can't show the business how what you're doing makes the business more money, that's actively against your best interest. I know we don't like the money businessy thing, but it's also good to know that what you built had an impact. It genuinely helped them generate value. The only way you'll do it is by getting something up the top that's then going to be propagated through machine learning, segmentation, messaging, or anything else. All right. Last bit, the cool bit. If I'm right, and you can throw stuff at me, that's what we do at engineering conferences, but if I'm right, it means that this thing increasingly is coordinating the flow, the pace at which the organization is interacting with the customer. The first time this happened, I basically went, we got to start Lightfold. The first time I built one and saw it actually happen. Data warehouses that I grew up building, if they compiled well once a week, you were pretty happy, right? People were talking about like daily batches. These things, you all know it, so they're compiling in 10 minutes, 15 minutes, 5 minutes. Some of them don't compile at all, streaming-based architectures. Why does that matter? The data goes up the top, makes a prediction. The prediction goes out to a human being. The human being changes their buying behavior. They buy something. 5 minutes later, it's back in the bottom of the data set as something which is going to retrain the model. That is a fluid system. That is a flow system. This is why I don't believe there is any such thing as the single view, and we need to stop talking about it. But what there is the central flow. This thing increasingly looks like a heart. It looks like something that's beating, and we're using it as a control system to coordinate the flow of data. And guess what? We go back 40 years to the world of best practice. We got things like data flow diagrams. We turned them into context diagrams for fun, but data flow diagrams were people realizing that the flow of data is almost as important as the structure and the size and the speed and everything else. Okay, I've got to give you time for a demo, don't I? How much time have I got?
No, that's good. They just want to listen to you.
Yeah, okay, sorry. Unfortunately, I don't actually pay Rishu, which is amazing because he's had to put up with this crap. What, this is your 5th time? Sorry about that. So Coalesce, Snowflake, you probably picked up. I've talked Snowflake a couple of times. We genuinely believe it's the best setup to do this type of propagation. I'm really interested in the top of the stack because that's where we make money. And I think the virtual data warehousing system is a brilliant way to just set up lots of independent mobilizations of the data. Here's the problem. I'm finding increasingly a lack of regard for structure. Other people have been talking about data modeling, why data modeling is the hottest thing out there at the moment. There's so much you can learn about your practice by just looking at traditional data modeling. Don't look at it for tips on what code to write. Look at it to understand the basics of informatics, understanding dimensions and dimensional modeling, understanding time. Oh my God, temporal modeling is so important. And once you understand those things, bringing shape to the data becomes the most critical part. It's almost like the refinery step before it goes back out and generates value. What you should not do, slide very quickly. We're going to talk about this thing in a second. This is Coalesce. You should try to do, like we all have seen, this DAG, directed acyclic graph. We should try to store the transformations in ways that are reusable, modular, can bring governance to the transformation. What I'm going to do, when do they kick us off stage? Is it 10 past 3?
10 past 3.
Is it really?
We still have
I better do this joke really quickly. You just don't want to do the demo. Okay. Anyone know what that is, quickly? What's that a picture of? It's a warehouse. Which one? IKEA. There we go. Exactly. It's IKEA warehouse. We call them a data warehouse for a reason. Can you imagine walking into these guys and going, you've got it wrong, IKEA. I can save you a mozza on storage. We've got a really good idea. Here we go, right? Take your Kallax. I use the Kallax because I put my board games in it. I'm a really big fan of Kallax. It's the only one I actually know. It's the only reason I go to IKEA. And I'm going to get a mincing machine. All right, what I'm going to do, stay with me, I've just got a really big pot, and I'm just going to mince all your furniture into the pot. All of it, the whole thing, whole warehouse, right down to all the bits into the soup. Fantastic, stored, problem solved, didn't need anywhere near as much warehouse. Just one problem, bloke in the high-vis goes, yeah, John, that's great, but where's my Kallax? And this is genuinely how things started in data lake world. I know it's gotten better, but they literally went, yeah, no worries, I've got this thing called a spout, and I'm just going to get this bucket, and give me a second. And there's your Kallax. It's not the Kallax. It can contain absolutely every single atom of the Kallax. It's not the Kallax. Why? Because the universe is composed not of 2 core elements, but 3. Matter and energy and information. Structure itself. The problem is that is a very efficient way to store the Kallax. But you have to somehow bring back its shape. And our obsession with just moving data like liquid from point to point, we've gotten really, really good at it, but where is the obsession with the nature of its structure and accountability for that structure, reliability on that structure, the decision reasons for it as it moves, which is now I give you the demo. What if you had something like that? What if you had something that had full lineage baked into the metadata of its code automation transformation steps, right? What if you could still do all the cool stuff where you do node-based transformations and DAGs, but at the same time, we cared intimately about exactly where each field came from. We could build our own systems for how we want to treat it, right? And we could then scale that and apply that at scale as our concept map for our data. And it could be unique to each customer. It could be unique to each business. I think that's extremely valuable. And now you get to do the fastest demo you've ever tried in your life. Over to you, Rishu.
Thank you so much. So we're going to look at Coalesce today. Before we talk about Coalesce, because given the time, there's absolutely no possible way of me presenting, demoing this to you. I'm going to talk about this product from the perspective of some of the philosophies behind this product. Okay, so we all know Snowflake, amazing cloud-based SaaS product, scalable, horizontal, vertical. It can do SQL, it can do Python, all that sort of stuff, right? It's amazing. You have now decided to invest in Snowflake so that is your data platform. You pay whatever, sign the contracts, give whatever dollars to Snowflake, you log into Snowflake, it's a blank slate, right? So then now you're left on your own, and there are a lot of ways of building your data platforms on Snowflake. But what is lacking out there is standards and best practices, because that is exactly what Coalesce brings on the table. So storage standards, naming standards, basic transformation standards, but also some of the best practices that you can quickly implement on your platform so that you can actually start going and building your data platforms, right? What I'm doing there is connecting to Snowflake.
Oh, you're not sharing screen. Sorry.
I'm not? Oh, is it split screen? Oh, okay.
Sorry.
How do I actually scroll on the side? Do I get out of?
Just get out of that guy.
Ah, cool. Okay. So sorry.
You're all really worried he was only just going to show you the slide after all that. It's okay. You did really well.
Okay. So I didn't do actually anything. So you can see now, I literally went there and I'm adding sources. What I'm doing right now is connecting to Snowflake, and at this point in time, I'm actually reading the source definitions. One of the philosophies of Coalesce is it's a metadata-only driven data transformation tool. This whole ops that is built under the covers, but it doesn't move any data. There's no data that will ever leave your Snowflake account while you're working with this product, right? And then the next thing that you can quickly do is we can talk about patterns and architectures. I can just go and say, hey, you know what? I want to add certain type of a node.
It's really pretty. I love that bit. Sorry.
So as you can see there, we have patterns. Data engineering, if you list down everything that you want to do, they're all pattern-based processing of data. We have patterns for data vault, dimensional modeling. Obviously, there are nodes for ML-powered functions that Snowflake launched, dynamic tables, CDC nodes. Basically, whatever you want to do on your particular data set, there is an existing node within. And what these nodes do is they actually end up creating some kind of a pattern. So now you've started building metadata. Always remember, we are just dealing with metadata here, right? If I open one of the nodes, you would see that this is the common UI that you'll be interacting with while you're working with this product. Everything that you see on this UI is configurable and customizable. None of this is fixed. You have the option to go and change the way a particular node works or create your own node from scratch. So what we're doing here is, because it's a staging node, let's make this truncate because we want to go and truncate everything, and let's quickly go and apply some kind of transformations. You can get as crazy as you want. I'm quickly going to do a bulk edit. I'm going to say, you know what, let's make everything uppercase, and I'm going to use source column on this. So I can quickly preview the results. You can see, hey, you know what, I have my column names, and now I have all the uppercase applied to this, just update on this. And now we have the transformations there. Like, again, go crazy as you want this to be. And then you can quickly go and create the object. So another philosophy of Coalesce is that while you're working on metadata, and you can always run your work, but you don't have to pay for working with Coalesce and building your pipelines as long as you're not running anything. So there's no compute under the hood that you're ever invoking while you're building your pipelines in Snowflake. So look, again, I actually know this at the back of my hand, so I'm like, you know what, I love this. I don't want to go and test anything, but let me also go one step ahead and build a dimension node. Now you can see that we talk about standards, best practices. It's a dimension node. It could be SYD-T1, so it added some system columns because we want to track the changes that are happening. It added a surrogate key. If you don't like the surrogate key, absolutely go ahead and create a hash column and use that, right? And then the options also, they change depending upon the object that you're using. So in this case, I can define a business key because I'm not going to delete this. There's going to be a merge operation that has to run. And now I want this to be a SYD-T2 type dimension, and I only want to track the changes when these 3 column changes. This is a non-trivial requirement, even for seasoned people writing code in whatever language you're writing. To build this kind of a thing is not that straightforward. What Coalesce does is that it actually templatizes this whole thing. So out of the box, I've just created an object, but I can go and, again, just to test my work, I don't have to run anything. So I'm just validating whether my run is going to succeed or not. It did not result any data, but you can see that it actually wrote a SQL behind the scene, right?
Rishu, isn't this just a clicky GUI? Like, isn't that terrible for me as a developer? Or are you telling me that it literally makes SQL when you use those cool little nodes?
It actually does not just make SQL, by the way. So it can also write stuff and support Snowpark and all that stuff under the hood. But you're right. Like, the intent of this product is to make sure that it doesn't matter who is driving the keyboard. End of the day, while you're scaling out, like, you can start with handwriting some code and everything that you want to do. But imagine giving this in the hands of tens of developers. Eventually, while you're building data mesh architectures, imagine business users going and implementing their own rules. How is it going to be scalable? And how do you actually create some code which is consistent, easy to manage, maintain? And that is one of the philosophies of this product again as well. So it has actually created some of the patterns, what do you do with the new data set, what do you do with existing records, and timestamp them, add another one. And it's also taking care of the columns. And it has actually written out 200 lines of code. And this is literally out of the box. If you don't like the way it has written code, absolutely go and change, right? And that becomes the standard. Check in the standard to the Git repository. Everybody in the organization is now going to use your new standard. And that's the whole intent of this product, right? Eventually, in this interest of time, you might end up building something like this, like a fact table, dimension table, and all this stuff. The next thing that you're going to do is, because you have created these objects, there needs to be some kind of a job that you would create to populate these objects, right? So you quickly have a job interface, and let's say I want to go and load my fact tables. This is awesome, but just loading the fact table doesn't mean anything. I want to go and load all the dependencies that are required to load this fact table. And it would visually give you the DAG that it's going to go and run. Also notice that the layers in the DAGs, those are the execution patterns. So it's not going to go and execute the fact before it executes the stage. It takes care of all that. Eventually, as I mentioned, any changes that you do eventually go back into the Git repository. Let me give you another example where we have a bit of a data vault kind of a model that is built in, but this is most likely how your DAG is going to look like, right? Imagine now managing a change. Tomorrow, somebody comes and says, hey, you know what, there's a change in a business rule, and I want you to implement this. It becomes super hard to actually visualize the impact of those changes across the pipelines, right? So in this case, you can not only see the dependencies or the lineage across the objects, but you can actually go into the object as well and say, I want to actually see the lineage of that particular column. And it's going to give you an exploded view of the lineage across the column. Also, one of the cool part about this whole functionality is that I can see that this column just stopped at this point in time. I want to go and propagate the changes across the whole pipeline. And you can just select the pipeline, preview your changes. Once you're happy, just apply them. It's going to go and create execution plan. And this is where, again, whatever changes I've done, you go to the Git, and you would go and commit, make changes. You can also go and check out if there is, oh, I didn't actually change anything here because I didn't apply. But let's go back to our original one. And if I go to the Git, it's going to show you all the changes that were done on this particular object. And you can go and see if there are existing objects. If you change anything on the existing objects, it's going to go very easy way of figuring out whether you like those changes, don't like these changes, discard everything, right? Or check it. Once you have done this, always remember this was only the developer experience. Then we have something called a deploy dashboard. Now this is how the CD is going to work. So once you have checked in everything, we can now trigger the pipelines to go and deploy the DDL changes. We call them as deployments, and DML changes, which is basically the jobs that we created last time, right? They're all going to be, it's very easy. So they are across environments. So you can eyeball and see if something fails, it's going to turn out red. Everything succeeded, it's going to be green. If you look at your refresh jobs, you have a proper ECF framework also provided to you. So you'll see every single object, whatever happened in this object. You will see the start time, end time, number of rows inserted, deleted, the warehouse it was using, along with the query ID from Snowflake. Everything that you're seeing is also available through APIs.
You're about to get tackled.
Oh, okay.
I think you did it. That's fantastic. Don't worry about any of the rest of the slides. Do we have to do questions, or do we have time to escape the building?
No, thanks very much. That was awesome.
Awesome. Thank you.